Welcome to Azal Engineering YouTube channel. Today I will show you how to create all possible load combinations for both static and dynamic analysis method on Autodesk Robot structural analysis professional software. In the first two consecutive tutorial parts, we have seen that first tutorial part, how to create modeling of this project shown on the screen, and in the second tutorial part, we have seen that how to define and design both horizontal and vertical loads on this real-life project. If you have interest, check the link in the description box and first comments of this video. Watch this video up to the end to master structural design on robot structural analysis software. Now it's a time for subscribe my channel to get daily update tutorials free. Thank you. Let's dive into this practical tutorial. Before proceeding to today's tutorial, that is creating all possible load combinations for both dynamic and static analysis methods, it's better to show you the load table that shows all the possible load patterns that is assigned on our project. So to do this, it's better to go to loads, load table. Yes, from here, we see that the self-weights of this project is defined like this. You have to define partition wall load, floor finish load, and live load under category A. After showing this, it's better to proceed to today's tutorial. To create a load combination, we have to use two methods, that is a manual method and automatic method. From the manual method, all things is defined by the user. And from the automatic method, the software itself generates a load combination using the input data. So first of all, it's better to define a load combination for factored load, that is for ultimate limit state, and for the serviceability limit state. Let's proceed to it. To do this, it's better to go to loads. From this, I have to get a manual combinations here. So click on it. So from this, have to make it 5, that is a combination number, or you can make it as any number, but in our case, it's better to select a combination number as 5. And from this, first, it's better to select serviceability limit state with a combination factor of 1 for dead loads, plus 1 factor for live load. This is because it's a serviceability limit state. So make it okay. Yes. From this, have to select all this, or you can select it one by one. So from structural load cases, that is the self-weight. So I have to add it like this. After that, from non-structural load cases, that is a partition wall load and floor finish, I have to add this. After that, the rest one is a live load combination, so with a factor of 1. So check the factor, that is 1. So have to select like this. So serviceability load combination is defined like this. Apply, close. After that, let's proceed to define the ultimate limit state, that is a factored load combination. So to do this, go to load again, manual combination, new, combination number, make it 6, combination type, it's ultimate limit state. So for ultimate limit state, in case of Eurocode, Eurocode defines as 1.35 for dead load plus 1.5 for live load. You can use your local building code of standard load combinations, but in our case, it's defined like this. Make it okay. So from this, have to select a structural load cases, that is the self-weight with a factor of 1.35, add, and non-structural, that is partition wall load and floor finish load cases, that is a dead load. So make it the factor as 1.35, add it, and the live load, that is under category A, that is 1.5 load factors, make it okay. So the ultimate limit state load combination is defined like this: apply, close. After that, go to loads combination table. From here, combination 5 and 6, that is for serviceability limit state, and ultimate limit state is defined like this. So let's proceed to modal analysis load combination and ASCE load combination, that is a seismic load combinations. Before proceeding to modal analysis and defining seismic load combination, I have to tell you some basic tips all about modal analysis. In case of modal analysis, we don't know randomly the number of mode required, so you have to check number of mode up to reach 90% of mass participation in X, Y, and Z direction. So Autodesk Robot structural analysis professional software by itself finds the number of mode required for 90% mass participation. After telling some tips all about modal analysis or dynamic analysis, let's proceed to the software, and we are going to define all things for modal analysis load combination using this software. So go to analysis type here. So make it new. From here, I have to select a modal for the analysis type. So the building code of standard we have used is Eurocode. So you can select your local building code of standard. After this, make it OK. Before proceeding to the advanced parameter, a number of mode and the number of iteration is like this. So we cannot now it. So to calculate this number of mode by the software itself, make it the analysis mode as seismic. After that, I have to limit the percent of mass participation as 90% in case of European building code of standards. So from here, don't miss that active the mass direction as X, Y, and Z. So after this, make it OK. But from here, let's miss one point, that is the mass conversion factor. So from this, I have to delete this that I have defined before. After that, go to this place, but before this, the mass direction is defined like this. So from here, I have to select the self weight and add it as close it. So from the self weights of the building, so the coefficient for self weight is 100%. So make it 1, make it add. This is because we are going to define the mass for the modal and ASCE or for the seismic analysis method in both static and dynamic analysis. So go to the second point, that is the second load case, that is a partition wall load. So make it add close. This load case type, that is partition wall load, is another types of dead load. So the coefficient is 100%. Make it 1, add it. And the third one is the floor finish load. Make it add. It's another types of dead load, so the coefficient is not changed. Make it add. The last and the fourth point is a live load. I will tell you some pointers here. So for live load, the coefficient is changed. This is because in case of a live load, you can use 30%, that is 0.3. After that, you have to reduce it within 20%. So I have to use 30% times 0.8. So the value is 0.24. The software calculates itself. So make it add. If you have any question regarding to detailed calculations in our tutorial, you can ask question in the comment section. So after defining all this, let's proceed to the calculation. Make it yes, yes again. So the software by itself calculate the number of mode required. So close it. To show the number of mode required calculated by the software, let's go to results here, advanced. After that, modal analysis. So from here, the software calculates the total number of mode required as 9. Yes, like this. So after defining the modal analysis or dynamic analysis load combination, let's proceed to define the seismic load combination for static analysis. So close it first. Go to analysis type here. So new. From here, let's define or let's use a seismic for Eurocode 8. After that, make it okay. Yes. So the ground acceleration value, this is depends on the building code of a standard or the location of the project. This project is located in Ethiopia, that is Addis Ababa. Ground acceleration value is 0.1. You can use your local building code of standards in your case, but the ground type, we have 5 ground types in case of Eurocode. So ground type A, that is for hard rock. You can go back and check Eurocode or your building code of standard. And ground type B, that is for soft rock, and ground type C for clay and silt soil types. You can go back and check it. In our case, our soil is type C from the geotechnical data. So from this, have to select ground type as C. But the spectrum type, in spectrum type, you can use the spectrum type 1 and 2. That is, depend on the magnitudes of earthquake. After that, the basic point that you don't have miss is the direction is horizontal, and have to use 3 directions. That is, I have to define directions as group 1, 2, 3. That is in X, Y, and Z respectively. So make it okay. Okay, so run G calculation. Make it yes. So the load combination for earthquake or seismic and linear combination is coming like this. I have to get all possible load combination is defined like this. Let's go to load combination table. So from here you can get all the load combinations, yes, like this. These were the most important parts regarding to creating all possible load combinations for both static and dynamic analysis. In the next tutorial parts, we will see how to analyze, design, and prepare a structural drawing for this real-life project by exporting to AutoCAD software in detailed explanation with a building code of standard. See you there. Thank you for watching. Have a nice time. Goodbye.